So this will be the first video on alcohols. So what makes a molecule an alcohol is the presence of a hydroxyl group, right? And remember that it can't be an OH as part of a carboxylic acid. So this carbon right here could not have a C double bond O to it, right? So alcohols are fairly common organic molecules. A lot of them you should be familiar with. The most popular is ethanol. That's the kind of alcohol that's in beer and wine. It's also added to gasoline because it's quite flammable. But there's other types of alcohols as well. Rubbing alcohol would be if you had this carbon where instead of having this be a hydrogen, you had a single bond to a carbon, and so there's 3 total carbons in that. So one thing I want to point out about alcohols, so they can be used as fuels, and there are some benefits to using them as fuels, but one thing I wanted to point out is that they're not quite as good of a fuel just from an what's called an energy density point of view. All right, so if you take a look at ethanol right here and you compare it to a similar sized alkane, all right, so you might be wondering, why don't I compare, since this has got 2 carbons, why don't I compare it to ethane, which would have 2 carbons? Well, because the mass of this oxygen is about the same as the mass of this carbon. So a gallon of this would contain just about as many molecules as a gallon of this. So this, since we're always doing this per mole, this would be a better comparison because they weigh about the same. All right. So if you were to burn a mole of ethanol, all right, we're going to show that by the enthalpy of combustion, which is shown like this. All right. So essentially the reaction would be you take this, you mix it with oxygen, and you make carbon dioxide and water. Those would be the byproducts of combustion. This is the amount of heat that you would get. All right. Same thing for propane. And one thing you should notice is that there's a lot more energy that would be available from burning the same number of molecules of propane versus ethanol. And that's because propane is more highly reduced. All right, you can't get any more hydrogen carbon bonds than you can with an alkane. All right, so you do lose a little bit in terms of energy when you do that, but alcohols are still very, very flammable. All right, so one important property that alcohols have is their water solubility. All right, so the reason that alcohols are soluble in water is that they are very capable of producing hydrogen bonds with water molecules. All right, so this is a molecule of ethanol, and if you look at the electronegativity of the atoms here, and if you're interested in knowing the electronegativity, you could find that in table 8 of your data booklet. So you can see oxygen has got an electronegativity of 3.4, hydrogen is 2.2. So what this means, remember, electronegativity is essentially how greedy the atom is for electrons. All right. So oxygen has a higher greediness for electrons than hydrogen. All right. It pulls on those electrons more. And since oxygen pulls on those electrons more, it makes the oxygen slightly negative. All right. And the hydrogen, which has its electrons pulled away from it, it makes it slightly positive. And we represent that with these delta negative, delta positives. All right. So whenever you have that, when it's around other molecules that have these delta negatives and delta positives, it creates a little bit of stickiness, and we call that a hydrogen bond. And in case you don't have the definition, I've included the definition of hydrogen bond down here. All right. So whenever you have an alcohol, you have that potential to have those interactions between the hydroxyl group of the ethanol and water. All right, so this part right here, the OH part, really likes water. We call that a hydrophilic part of the water. All right, but alcohols are also connected to a carbon chain. All right, so this carbon chain right here doesn't like water. All right, so that's what we call hydrophobic. All right, well, the thing about it is, if you have a relatively small molecule, a larger portion of the molecule likes water compared to a larger alcohol. All right. So because of that, small alcohols tend to be water soluble, whereas larger alcohols tend to be water insoluble. And that's just because so much of the molecule doesn't like water compared to the part that does. All right. So one thing that I want to point out, though, is even if you get a large molecule, every time you add a hydroxyl group, all right, it's going to increase the attraction to water. All right. So you can have hydrogen bonding with water molecules to every single one of these hydroxyl groups. All right. And that's going to tend to increase the water solubility of a molecule. So even though this molecule right here, which is sucrose, is much bigger than this molecule octanol, sucrose is water soluble. And that's because it has just so much of the molecule contains that hydroxyl, which really likes water. All right. So just to finish up here, there are a lot of different reactions that alcohols can undergo, but one of them that I want to point out is the reaction between a carboxylic acid and an alcohol. All right, and I've kind of differentiated the R groups with a prime and a double prime. All right, there's a fairly famous reaction where you can make an ester. All right, and so this part of the ester came from the alcohol, and this part of the ester right here came from the original carboxylic acid. All right. Another common reaction is where you can take an alcohol and react it with an alkyl halide, and that's going to create an ether.